Welcome to EDU World Space.
Alright, so here we have the problem 23.58. We're going to find the valence d electrons associated with the central metal ion in each of the following complex. So for A, we have K3, Fe, Cn, 6. Alright, so if we assume that the iron has an oxidation state of X, we know potassium has positive 1 times 3 plus X plus 6 times the oxidation state of cyanide ligand is negative 1. That will give equal to 0. So we have 3 plus x minus 6 equal to 0. And we get the number x equal to positive 3. So the electron configuration for iron was Ar3d6 4s2. This is iron. So after it loses 3 electrons, iron 3 plus will have the electron configuration as Ar3d5. So the total number of valence d electrons is 5 right here. All right, question B. We have the structure of manganese, H2O, 6 NO3, 2. Alright, so for this complex, we also assume that the oxidation state for the metal is X. 6 times the oxidation of water is 0, plus 2 times the oxidation state for NO3 is negative 1. That equal to 0. So we have X minus 2 equal to 0. So the number X is equal to positive 2. Alright, so the electron configuration for the metal manganese at its original state was Ar3d5 4s2. So after it loses 2 valence electrons, so you will get manganese 2 plus, and its electron configuration is Ar3d5. So the valence electron in the d orbital for manganese is also 5. Alright, so now question part C. We have the complex Na silver Cn2. Alright, for this one, we know that the oxidation state for sodium is positive 1. For silver is X plus 2 times cyanide is negative 1 equal to 0. So 1 plus x minus 2 equal to 0. We have the number x equal to positive 1. So the silver has an atomic number of 47. So silver has the electron configuration 4d10 5s1. So once it loses 1 valence electron, we have silver plus, and the electron configuration will be 4d10. So the total number of valence d electrons in this case will be 10. Part D, we have CrNH3 4, bromide 2, and ClO4. Alright, so the oxidation state for chromide X, oxidation state for NH3 is 0, 2 times the oxidation state for bromide is -1, plus this is -1, that will be equal to 0. So we get the number X equal to +3. So the oxidation state for chromium is +3. And we have the electron configuration for chromium is Ar argon 3d5 4s1. So after it loses 3 valence electrons into chromium 3 plus, we have the electron configuration of Ar 3d3 and no electrons in the 4s orbital. So the number of electrons in the valence d orbital is 3. So now part E, we have EDTA 2 minus. So we assume that the oxidation state for the metal is X plus the oxidation state of EDTA is -4. That will be equal to -2. So we get the number X equal to +2. So since SR has an electron configuration 5s2, after it loses 2 electrons, 2 plus will be exactly the same as chromium. And for the electron configuration of this part, the complete electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. So you can see the valence d electron, the valence for d orbital has 0 electrons. So the answer for this part is 0.